Hello everyone. Today we're going to be creating tables and graphs along with what we did yesterday, naming the independent and dependent variable. So creating a simple graph, I want to remind you that this axis, the horizontal axis is the x, the vertical is the y. Our first column is always that independent variable, and our second column is the dependent variable. So the first column always is the horizontal, how much you're going over, and the vertical is how much you're going up. I also want to remind you that you need to label your axes, meaning tell us if you know what the numbers mean. So in this case, my x axes are the minutes, and our y axis is the number of pages. Now we have to, and this is a review for you, I hope, we have to decide how we're going to number our axes. The x-axis has to go up to 8, and I believe there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 lines. So if we go by 2s, we won't have enough space. So I'm still going to number by 2s, but my interval is really 1 because each box is a 1. So there's my 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So number the whole axes. And remember, you want to use the whole axis if you can. All right, pages I have to go up to 20. So I can probably number by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Yep. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Even though we don't need the 22 and 24, we're still going to include it. All right, so this is how far we're going over. We're going over 0 minutes. There's 0 pages. So I'm going to put my plot point there. At 2 minutes, there were 5 pages. So it's going to be right in between that 4 and the 6. At 4 minutes, there were 10 pages. I'm going over 4, up 10. At 6, there was 15. So again, right between that 14 and the 16. And hopefully you're seeing that it makes a straight line. At 8, there were 20. And then you're going to connect it with a straight line all the way up like that. So again, to recap, x independent horizontal, y dependent vertical. All right, now let's look at a problem. Maggie's buying cans of bubbly water that comes in packs of 8 for her mom. Write an equation to represent the total number, that's important, of cans that Maggie will purchase if we know how many packs she buys. And then determine the variables, write the equation. So we know that the total number of cans we can figure that out by taking, if there's 8 per pack and she buys P number of packs. We could have used X and Y. We can use T. How many packs? Okay, so this is how we figure it out. So my equation would be T equals 8 times P. So total number of cans, how we figure that out is 8 packs, 8 times the number of packs. So our dependent variable is T, total cans, and our independent is P, number of packs. So now we can make our table. So we know that independent, the number of packs, is our first column, and our dependent, total cans is our dependent, so the second column. So if we get 0 packs, 0 times 8 is 0. If we get 1 pack, so if we have 1 in there, if we have 1 for our P, that would give us 8. So for every extra pack we buy, we're getting an extra 8 cans. So we can fill the table out pretty quickly because we're counting up by 8s. So 3 times 8 is 24, 4 times 8 is 32, 5 times 8 is 40. Every time we're going up by another 8. So now we have our numbers that we need to make our graph. So again, please remember to label. This is really important. So the independent variable is my x, and it is going to be number of packs. My dependent is the total number of cans. So then the next part is figuring out what we want to number by. Since we only need to go up to 6 on the x-axis, I suggest we number by 1s, but every other space. So really my interval is a half. So each of these blocks are worth a half. So 1, 2, 3, 4, 5, 6. And again, you did this in the integers unit. Now we have to get up to 48. And again, there are 12 spaces. So 12 goes into 48 4 times. So each of our spaces, so each of these could be 4. So we can count by 4. So 4, 8, 12, 16, 24, 32, 40, and 48. And it just so happens that it's the same numbers. So these are the same numbers as this column, but many times it won't be. Now we can plot our points. At 0 packs, there are 0 cans. At 1 pack, there were 8. And 2, there were 16. And we continue just plotting our points until we see that we have a good straight line, and then we are going to connect them. All right, I'm only going to do one more problem with you because I don't want this video to get too long. Emily is planning to go to the fair. She pays $5 to enter the fairgrounds. So that's a one-time only fee. One time only. And then an additional $3 per ride. So remember, that per means multiplication. So here, that's my independent variable because she's paying $3 per ride. So how much will she spend at the fair? So the amount she spends, we have to do our $5 up front plus $3 per ride. So that per, so every time she takes a ride, she has to pay another $3. So 3 times the number of rides. So our equation can be A equals 5 to get in plus 3R. In this case, our amount, we're not just going to pick a random amount. Our amount depends on how many rides we take. So our dependent variable is A, the amount. The amount she spends. Holy cow. And our independent variable is the number of rides. So now we can make our table. So my independent is always my first column, and it is number of rides. And my second column is always my dependent, and it is the amount. So I think I'd like you to add a note down here because I keep saying it, and hopefully you're listening carefully, but it might help if we are reminded. First column is your independent, and the x-axis, and second column is the dependent, and the y-axis. All right. So if she takes 0 rides, she still had to pay her $5 to get in. And I don't like rides, so this is what I end up doing when I go with my kids. Well, I like the Ferris wheel, but $5, even if she doesn't do any other rides. But every ride she takes, it's another $3. So if she only does one ride, it would be 5 plus $3, so $8. If she does a second ride, that's another $3. So every time she takes another ride, it's another $3. On top of that 5 she already had to pay. And then we can graph it. I am hoping that you remember to label. So the independent is our X, number of rides, and our dependent is the amount she paid to get in, or the cost. And then again, we only have to get up to 6, so I can number by half, even though we're only going to see our wholes. 1, 2, 3, 4, 5, 6. And I have to get up to 23, and there's 12 lines. So I think going by 2s, that'll give us 1 extra half. So if this was 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. And with graphing, sometimes you have to guesstimate. So for example, for my 0, 0 is easy, but for one ride, it was $8. Well, that's on there. So we don't have to guesstimate that. 2 was 11. So here's my 12. So right there is 12. So we know it's going to be a little bit before that. And I see I already made a mistake. So it wasn't 0, 0. It was 0, 5. So I apologize for that. I'm glad I caught it. Okay, so 2, 11, 3, 14, 4, 17. So this line is 16, so we have to go a little bit past that. 5, 20. And the reason I caught it is because when I started to put that next dot in, I could see that it wasn't going to be a straight line. So that's why I paused. I knew I did something wrong. There we go. Just like that. Okay, thank you for watching. I hope you have a great day.